This is Andres, and this is my explanation for speeding up in a positive direction for the fan cart. So here we have the position time graph of our fan cart, and this position time graph means is that it represents it speeding up from this arched line, as opposed to it being a straight line, which represents a constant velocity, a constant speed. So the arch line going like this means it's speeding up, and since it's arching in a positive direction, it means the fan cart is going in a positive direction. The y-intercept of this graph at means that at 0 seconds it started at roughly -2 inches from from what we decided would be like the origin point. So the y-intercept for this graph is where it started when we took these data points. And from the position time graph, we're able to get the velocity graph, which is the derivative in calculus terms of the position time graph. And what the velocity graph shows us is it basically supports the fact that it's speeding up. Since it is a straight line going in this, roughly, it's according to our data, especially from this point here to here, it's more or less straight line, indicating constant velocity, so increasing speed. And since it's going in a pause, since its slope, the slope of this line is positive, that means it's going in a positive direction. The slope being roughly 4 inches per second, and what that means is every second the fan cart would increase its speed by a rate of 4 inches per second. So from this, we're able to get the equation for this velocity graph, which would be velocity is equal to 3.523 or roughly 4 inches per second times time times not times plus the y-intercept, which is 1.398 inches a second. And what that y-intercept is basically the initial velocity of our fan cart. Going back to the slope of this velocity graph, the slope here is basically being supported in the acceleration graph, which is also the derivative of the velocity graph. From these points, it's a straight line at roughly 4 inches per second. So it's a constant acceleration.
I almost forgot to mention displacement. Actually, I did. So with the velocity graph, we're able to find the displacement, which is the total distance the fan cart traveled. So to find that, we take the total time, so whatever the time is over here, and multiply it by the total of the end velocity, which is whatever it would be up here, and multiply that by 1/2. So we would take 2.433, so roughly 2.5, multiply it by 9.633, and take that and multiply that by 1/2, and then we would get 11.664 inches. So what that means by 2.43 seconds, the fan cart traveled a total distance of roughly 12 inches from our origin point in the positive direction. So yeah, now that basically sums up constant acceleration.